So hi all, welcome back to another video in this Oops Refresher series, and in this video we'll be talking about encapsulation. So if you want to have a quick look at the earlier topics that we discussed, you can head over to the previous videos, but for now let's continue with the concept of encapsulation. So um, encapsulation is the fundamental process of object oriented programming, right? So it says that it involves bundling data and the methods that operate on that data within a single class. So this is important. So what it says it involves bundling data, that is the attribute, right? And also the methods that operate on that data within a single class, right? What are we doing here? While restricting direct access to some components to prevent accidental modification. So this line will understand via an example. So for now, just understand that it involves a mechanism where we bundle data, that is the attributes, and the methods within a single class, to prevent some accidental modification that is happening. So we'll understand why such accidental modification happens, right? So if you see here, so we'll see understanding the access modifiers. See, it says access modifiers control the visibility and accessibility of class members, that is the attributes and the methods. So we'll see this, what are access modifiers. Let's take with a simple example. For now, let's first start with a Java example, right? So here you have a class user, and then you have defined this public as a username and protected as email, and then private for password, right? So if you see, we we give public access to username, means that it is accessible anywhere, but we give protected and private access. For now, let's not go into deep into what is difference between protected and private, but you can understand that this is a restricted access, because if you see, email and password are not something that we want to share across classes, right? So we are restricting access for it. And then if you see this constructor, this as usual takes username, email, password, assigns this, and then there is also a public method, right? So public string, public method means this method is accessible for from anywhere, whereas protected method means this is accessible within packages and subclasses. And private method means this is only accessible within this class. So if you write private, that means this is only accessible within the class. But whereas protected means it is accessible within the package and then subclasses. So this is the difference between private and protected. Both give this restricted access. Only difference is private means only this user class can use, none other subclasses can use it. But whereas protected means this is accessible within the package and the subclasses too. So that is the difference. If you see this, what are we doing here? Go back to the definition. It involves bundling data, right? Whatever the attributes that we have here, and the methods that operate on the data. If you see, these are all the methods, right? These methods which we defined that are operating on this data, right, within a single class, right? This is within a single class, right? We are doing within a single class, while restricting direct access to some components to prevent accidental modification, right? So this is exactly what we are doing. We are restricting access to some attributes, some method, so that accidentally there should not be another class which for some reason tries to get access to the password. This is a bad design, right? So password should be private by design, so that even accidentally no class can call this, or no class can also accidentally modify the password, right? Or even the method which modifies the password should not be accidentally called by another class. So in Python world, if you switch, so here if you see, in Python, one thing to understand is the language does not complain whenever, if you, let's say, if you define something as a protected or a private variable and then you try to access from another class, it does not complain, but it is just a naming notation, right? If you see here, this is a public variable as usual, and protected means will have one underscore, and private means you'll have two underscore. That's all. So public method, protected method, private method. If you see, these methods also have same notation, single underscore, double underscore. So the language does not complain that you are accessing a protected or private variable, but it is more of a just a naming convention for developers to understand that okay, this is a protected variable, I should not try to access it, but it will not enforce it. But whereas in Java, it will be enforced at the compile time itself. So if you see, go back to the Java example, it is very clear, like we are naming it with public, we are naming it with protected, we are naming it with private, etc., right? So that is the difference. So again, key difference is public means this is accessible from everywhere. Protected means these are accessible within the package and the subclasses. Private means this is only accessible within the class, right? So by default, everything is accessible within the same package. That's all. So these are the differences between different access levels. So this public, protected, private, all these things are called as access levels or access modifiers, right? So if you, now let's see about protected attributes or members. So protected attributes are intended for internal use, but can be accessed by subclasses. We saw this, right? Same thing here. Protected, they can be accessible within package and subclasses. So let's see an example. So you have a user class, you say protected string password, right? This is a protected attribute. And then you have a constructor class which takes username and password and assigns the password that it gets in the parameter here to the password variable. Now you have get password which returns the password, and then now you have another method called as set password which sets the new password that is passed in. So in the same package or a subclass, if you see here, there is another class called as admin user which is extending from the user class, right? So this is subclass, right? So in the same package or subclass, you can use this. If you see, this dot password is equal to new password, you can access the protected member, right? Whatever the protected member that you define here. So here, just to iterate again, you have a class called as admin user which is extending from the user class, right? From this user class we are extending the behavior. Now this is the constructor. As usual, it takes username password, and then when it calls super username password, that means it is calling the constructor of this parent class, right? The same thing goes here. Now if you have a specific method on this admin user called as reset password, and when then this says this dot password, that means you are accessing this protected attribute that you are defined earlier, that you have defined earlier. So now you can say this dot password is equal to new password, right? So if you want to understand how does this super work, you can see the video on inheritance where I'll be explaining in deep on how does this super work. But to understand it in short, super means it is used to call and make use of the behavior that is defined in the parent class, right? So we don't need to duplicate all this thing, right? We don't need to duplicate this constructor that is defined here. So when you call super, it means it just automatically points to the user class, and then you are passing the username and password, and then you'll have all these things reusable again. So protected members are accessible within the same package and by subclasses, more restrictive than Python's convention based approach. This is enforced by compiler. We saw this, right? In Python, if you see the same example in Python, if you see user dot, here we have a class user, password is a protected attribute, but here if you see at the end in line number 13, we are printing user dot pass. This works, but it is not recommended, right? So Python does not enforce it. This is just a convention. I mean, it just tells that developers that this is a protected attribute. You have to make sure that you don't access it outside, but it will not complain. But whereas in Java it is more strict, right? So you will not be allowed. I mean, the compiler complains that you are accessing something wrongly. So that is the difference here between Java and Python. So now let's go to the private members. So private members are truly internal and should not be accessed from outside the class, right? So the same access level that we saw here. Public, accessible from everywhere. Protected means internal use. only within subclasses. But private means this is truly internal, except the class which has these attributes defined on, no other can access this. So if we go to private, it says private members are truly internal and should not be accessed from outside the class. So if you see Java sample here, so you have a class user, and then you defined an attribute password, and then the modified level is private. Constructor class takes username and password, assigns this dot password is equal to password, get password, and then there is this private method, private hash password. So if you see this attribute, the access level is private, and there are two methods in this method, and the access level is also private, right? So in the main, whenever you are creating an instance of this class user, right, you are creating instance of this class user, and then if you print user.password, you'll get a compile error saying password has a private access, right? Why? Because we have annotated with private. But whereas if you make use of user.get password, it works. Why does it work? Because this is a public method, right? So private means only within the class it can be called. Even outside the class we can't call it, right? This is strictly internal. So private members are only accessible within the class. These are enforced by compiler, and we use getters or setters to control access. Let's say if you want to access anything like password. See, password is private, right? But let's say if you want to access password, we make use of getters or setters. That is this get password, right? These are called as the getters or setters. Same thing in Python. Same double underscore means it is private. You wrote we have a method called as get password, which returns the password that we defined here. So now if you say user and then you say user dot password, you'll get a attribute error saying user object has no attribute, private password. But when you print user dot get password, this works. Now you can, this is also, if you see this final line, you print user dot underscore user underscore password, this works. But we should not do this, right? So this is the right way. See, one thing that I have forgot is, if you see whenever we define it as double underscore, that means it is a private attribute, and there is a small concept called as name mangling. So we'll see this, right? So it says name mangling in Python is a compile time textual transformation, right? So that automatically transfers or rewrites any class attribute or method starting with two leading underscores, right? That is like something like this, to include the class name as a prefix, right? If you see, so if you say self dot underscore balance, so at the compile time it gets changed to self dot and then account, underscore account and underscore balance, right? So it adds this underscore class name as a prefix. So if you see, this like this, underscore account and then underscore balance. So like this, what we saw here, the same transformation happens. So whenever if you try to access this private variable like account dot underscore balance, this will raise an attribute error, you know. But if you say account dot underscore acc dot underscore account underscore balance, this will usually work, right? Okay, so why does name mangling exist? So it says Python does not feature strict access modifiers like private and protected, right? So we saw that. And now name mangling provides a safety mechanism specifically for subclass hierarchies. Consider this example, where both base class and subclass independently try to track an internal value using the same variable. If you see, there is this parent class. When you defined a private attribute, right, underscore id, and then you have a child class which is calling super.init. That means it goes to this parent class and then you are calling this init, and then you have another variable which is exactly same in the child class, which is exactly same as whatever is present in the parent class. Now in this scenario, this will be mangled as underscore parent underscore underscore id, right? Like this. This is the notation, right? So you'll have underscore class name and then underscore underscore variable name. And now here, this will be mangled as like this, right? Underscore child, because this is the class name, and underscore underscore id. So now whenever you call object dot underscore parent underscore id, this gives you parent id. Whenever you call object dot underscore child underscore underscore id, this gives you child id. Here object is just an instance of a child class. It says both attributes can safely coexist on the same instance without overriding. Why? Because this mangling happens, right? So effectively it is not underscore underscore id, it is underscore parent and then double underscore id, right? So because of this mangling happens, both of these variables can coexist, right, on the same instance without overriding. This is one thing. And finally, this is just a industry convention. So single underscore means this is to indicate a protected variable. Double underscore means this is reserved exclusively when you explicitly want name mangling to activate, right? So whenever you want such name mangling thing to activate, you'll make use of double underscore. So another thing is this point is important. So it is not a true security, right? So mangling does not truly hide the data or create a security boundaries, right? Anyone can still read or modify the attribute if they intentionally type out the mangled format. So it says, if you go back to the example here on encapsulation and our notation on double underscore password. So if someone intentionally types user dot underscore the class name, that is the user, and then underscore 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 password, they can still access this, right? So there is no security mechanism, right? There is no concept of this modifiers in Python, right? So we should not do this. We should make use of the getters, right? Getters and setters that we saw earlier. We should make use of these methods, right? So this is what it says. So this is not to truly hide the data or create a security boundary. Anyone can still read or modify if they type out the mangled format. So this is the mangled format. This works, but we should not do this. So what is name mangling? This triggers name mangling. Python changes the name internally. We saw this, right? So it becomes underscore class name underscore underscore attribute internally. So this is still accessible, but harder to access by accident, right? This is important. So if you have this thing, you can't, I mean, if you type like this accidentally, you'll get an error. Then, okay, you'll understand that I am accessing something, private, and then you'll stop doing that. So while you can still access using this mangled format, it's strongly discouraged. So use this for truly internal implementation details. Now finally the properties. So in Python you usually don't write getters and setters unless you need validation or transformation, right? So if you go back to an example and then check in Java, right? So in Java you have the concept of getters and setters. But in this property section in Python, so it says in Python, you usually don't write getters and setters unless you need validation or transformation. So properties provide a clean way to add getters and setters. So we'll see how do you add getters and setters, right? So same, you have a user class constructor takes username, email, and then this is a protected attribute. So you have a method called as password, and then it returns self dot this password that we defined here. So you annotated that with property, right? So this means this is just like a getter, this is accessed like an attribute. So by attribute that I mean, so you can say user dot password, right? So earlier these are methods, right? You can't access like this. But if you define or annotate as a property, you can say user dot password directly, right? This is, see how simple is it. Earlier, if you want to do in other language, you have to do user dot get password, right? You have to define the method. But if you annotate here as a property, when you can after dot like user dot and then password means it understands that you are calling this method. So if you annotate as property, that means by default it is a getter. If you annotate as a setter, means it understands that you are setting something. So when you create an instance of this class user, and then when you call user.password is equal to new password, okay, that means okay, user.password, you are setting a new password, and then it makes use of this method. When you print user.password, it means it makes use of this method, so it will understand it directly. Why? Because you have annotated this as a property, right? So you annotated this password as a property, and then you are saying this method what you wrote here is a setter of this property, right? If you see, both these methods are same. This is also another important detail. Both these methods, right, password, both of them the namings are same, but one thing is a property, that means you can access as dot, and second thing is a you are annotating this thing with at the rate password dot setter. That means this is a setter method for this property that you have defined earlier. So that is how it will understand. So you can use this clearly. In Java, if you see the same thing, so this is how you'll define. So you'll write, I mean, it's just a notation. You can write like and get under then whatever attribute that you want. Get password and then set password. Right. If you see here, how are we doing? We are calling dot get password and then this method, right? So you're calling this dot get password on this class, right? So this is how you define getters and setters in Java. Same thing in Java. Python we saw earlier. Only thing is you don't need to write dot underscore password and then all this method. Instead of method, this will be a property that you can directly access, right? So you can directly call user.password. That's all. You'll make use of this property. You are getting a clean syntax. These variables are also not, sorry, these attributes are also not exposed outside. You are getting a very clean syntax. Now, one final example, encapsulation, in practice. So let's say you have a class called as bank account, and there is something called as balance, right? So you have defined this as an public attribute in Python by default. In Python by default, whenever you define an attribute, it is public, right? So this is a public attribute. This is dangerous. See why? We have a method deposit, we have a method withdraw. So far so good. And then you have an account, which is a bank account, and then you say this is the initial balance, right? This is the balance, and then when you say account dot balance minus 500, that means you are directly modifying, right? This should not happen like this. So if you want to withdraw something, then if you want to do changes to the balance, you either have to deposit or you either have to withdraw, but you cannot directly modify the balance, right? This is a unsafe thing. Same thing in Java. If you see, bad example, we defined balance as a public. Because the modifier is public, you can directly, whenever you create an instance of this class, you can say account dot balance is equal to minus 500. Now this direct modification is unsafe, so we should not do this. So if you see proper example, go back to Python. Same thing, you are defining it as a private attribute, right? So whenever you do double underscore, that means it is a private attribute, and only this class can modify it, right? So you have a deposit which works on this balance variable. You have withdraw, which also makes use of this or modifies this balance attribute. And then you finally have a property. Let's say if you want to show the balance to the user, right? Once after the transaction is done, you make use of this property. So this only gives read only access to the balance. So if you say create an instance of this class bank account, say 1000, and then say deposit 500. So it means if amount is greater than 0, self dot balance is plus or plus is equal to amount means you're adding 2000, you're adding 500, and then you are withdrawing 200. That means final amount is 1500, right? So if you do account dot underscore underscore balance, it will not affect because you are having this name mangling mechanism, right? So you can't directly do that. And then you can't directly set, right? You can't do like account dot balance is equal to minus 500 because we don't have any setter for this. If you see with properties, how do you define a setter? Like this, you say this property name dot setter. But here if you see, for balance we didn't write any setter, we just defined a property, and this is just a read only property to get access. So if someone says account dot balance is equal to minus 500, it will not work. You can read, you can say account dot balance, but you cannot say account dot balance is equal to minus 500. That is important. Same thing in Java. So you define it as a private, clear, you can clearly understand that this is a private. Even compiler also doesn't allow you to access this outside, right? Same constructor, same deposit and withdraw methods. For you to get balance, you have a getter, and then you'll return the balance here. This is just a read only, right? So this is a public. We have the access level is public. So here in main, you created instance of this bank account, deposited starting with the balance is 1000, deposited 500, withdraw 200, so final is 1300. So whenever you call account dot balance is equal to, you can't do, right? Because it says compile error, balance has a private access, because you have declared the access level for balance variable as private. So this is a proper and good way to do this. So final representation. So if you see bank account, this class, we have something called as balance, which is public. So because it is public, it can be modified directly, but with proper encapsulation, these things cannot be modified directly. So key takeaways. So encapsulation bundles data and methods together while controlling access. We saw this. So we are bundling both the data and method together by controlling the access. How are we controlling access? Private, public, and protected. So in Python, this is just a name convention, right? So there are no hard rules, but this is just a convention that all developers use, that one single underscore means protected, double underscore means private. So nothing is enforced. You can still access this outside, right? Whereas in Java and other languages, you have something clearly defined, right? Public, private, protected. So if you do something wrong and access some private variable outside, the compiler will show you that you are using something that is defined as a private. You should not do that, right? So protected attributes are for internal use. Private attributes are truly internal. Only inside the class you can use that. So properties in Python. So in Python, you use properties as getters and setters, whereas in other Java and other languages, you will define the getters and setter methods. So finally, you will use encapsulation to create clear interfaces and prevent accidental misuse. So if you want to understand the concept of interfaces, you can head back to the previous video, but we'll make use of encapsulation to create clear interfaces and then prevent any such accidental misuse that we saw earlier, right? So one should not accidentally modify the balance, right? This is important. So that's all for this video. This is simple but very very important, and you'll be judged on what are the access levels that you are defining for your attribute. So whenever in a real interview setting, you just have to tell why are you annotating, or why are you giving access level as public or protected or private, right? So you should not by default go with public for all. So this is something that interviewers also notice. So you have to make sure that the level that you give is proper. So that's all on encapsulation. You can copy this samples to your IDE, play with it, add some method, right? So that you'll understand this properly. So in the next video, we'll be talking about polymorphism. So that's all for this video. Thank you.